Welcome to my YouTube channel, A Brain Area of Civil. In this video, I would like to solve assignment number 1 in the subject Strength of Material. Okay, so first question, you can see normal stress on a principal plane is. So option A, it is maximum. Option B, it is minimum. Option C, it is 0. Option D, it is either maximum or minimum. So on principal plane, what is the normal stress? Either it is maximum or minimum. So we need to choose the given options. So first of all, we need to define what is the principal plane. You can see here, principal plane. So principal plane is the plane on which shear stress is 0, that is tau is equal to 0. That particular plane we call it is a principal plane. Okay, and the stress on principal plane either maximum or minimum. Okay, so the stress on the principal plane is either it may be a maximum or it may be a minimum. There is no shear stress on the principal plane. Only normal stress is available on the principal plane. Either it may be a maximum or it may be a minimum. If the normal stress on the principal plane is maximum, if it is maximum, then we call it is maximum principal plane. Or else if it is minimum, then we call it is minimum principal plane. Okay, so the normal stress on the maximum principal plane is called maximum principal stress, and the stress on the minimum principal plane is called minimum principal stress. Okay, clear? So the option D is the correct answer. So either it may be a maximum or it may be a minimum. Next question. Limiting values of Poisson's ratio are. He has given some options. It is -1 to 0.5, -1 to -0.5, -0.5 to 1 and 0.5 to 1. Generally, first of all, we need to know what is a Poisson's ratio. So Poisson's ratio, it can be shown by the symbol mu is equal to lateral strain divided by linear strain, or it is also called as longitudinal strain, or again it is also called as axial strain. Okay, that is, it is the ratio of lateral strain to longitudinal strain. So what is the difference between lateral, longitudinal, what are all this? For example, I have taken a member. So I have applied load P along the length. Okay, so this length direction we call it is a longitudinal direction or axial direction or linear direction. And perpendicular to this length, you can see here, it is, this direction is one direction and this direction is another direction. This is the depth direction. This is width direction. So now lateral strain means there is a strain along width, along depth. Okay, so finally the Poisson's ratio is the ratio of lateral strain to longitudinal strain. Okay, and what are all the limits for Poisson's ratio? Generally, Poisson's ratio ranges from -1 to 0.5. Okay, these are the limits for Poisson's ratio. So you need to remember these values, -1 to 0.5. And for some engineering materials, you need to remember what is the exact value of Poisson's ratio, like for concrete, like for steel, like for aluminium. And is there any material having Poisson's ratio as 0? Yes, there is a material having Poisson's ratio 0, that is cork. I am writing some values. Mu cork is equal to 0, that is Poisson's ratio for cork material is 0, and mu concrete is equal to 0.1 to 0.2. So the value of Poisson's ratio for concrete will ranges from 0.1 to 0.2, and mu steel is 0.27 to 0.3, and mu aluminium is equal to 0.33. So generally in entire civil engineering, the most common materials that we use were concrete and steel. So concrete will have Poisson's ratio 0.1 to 0.2, that is it is having less than steel. For steel, Poisson's ratio is 0.27 to 0.3. You need to remember these two values especially. Okay, so for the given question, the answer is -1 to 0.5. The answer is A. Okay, and next question. You can see two bars having same size with moduli of elasticity E1 and E2 are subjected to the same tensile load. So that is the load applied on the two bars is same load and having modulus of elasticity E1 and E2. If the elongations of the bars are in the ratio of 4:7, that is elongation in bar 1 to elongation in bar 2 is in the ratio 4:7, then determine modulus of elasticity of 1 divided by modulus of elasticity of 2. He asked us to calculate the ratio of E1 to E2. We have a basic formula, elongation delta L is equal to PL by AE. So from this expression, delta L is inversely proportional to E, right? And he has given us delta L1 by delta L2. As delta L is inversely proportional to E, we can write delta L1 by delta L2 is equal to E2 by E1. Okay, then it will become 4/7. Okay, but he asked us to calculate the value of E1 by E2. Here we got E2 by E1. So what is the value of E1 by E2? So it is reverse of delta L1 divided by delta L2. That is, it will become finally 7/4. It is not 4/7. Okay, so what is the answer? So the answer will be 7/4. It is option C. And now you can see next question. Which of the following represents equality of cross shear capacity? Okay, we know shear stress onto mutually perpendicular planes in complementary direction are equal. So that is, I am writing the statement here. You can see shear stress on two mutually perpendicular planes in complementary direction are always equal. Okay, so this is a standard statement we need to remember, and this we can prove by using moment equilibrium condition. For example, I am taking a stress element. So I am taking a stress element having this is length of the element, this is width of the element, and this is depth of the element. And the points I am marking here, it is A, B, C, D. So, and this stress is tau yx. I am taking this stress is tau xy. Okay. Let us take, I am taking for stability of this element. So for stability, summation of moments about point A is equal to 0. I am taking moment about point A is equal to 0. Moment about point A, what is a moment? Moment is equal to force into perpendicular distance. What is force? Stress into area. So now what is the stress I am taking? It is tau yx. Tau yx is acting on which plane? On this plane, right? So what is the area of this top plane? This is L and this is P. L into P is the area. Stress into area will become force, and the perpendicular distance is D, and it will produce clockwise moment. Okay, and tau xy will produce anti-clockwise moment. This is acting over area B into D, and perpendicular distance will become L, that is equal to 0. Okay, from this expression I can able to write tau xy is equal to tau yx. Okay, so that is shear stress on two mutually perpendicular planes in complementary direction are equal. Okay, so not only tau xy is equal to tau yx, similarly tau xz is equal to tau zx, tau yz is equal to tau zy. क्लियर? समझ आया पूरा? What is the principle that we have used in proving this equality of cross shear capacity? The principle that we have used is moment equilibrium principle. Okay, I am writing here principle used is moment equilibrium principle. Very important. This is one more objective question. Okay, so which of the following principle can be used to prove cross shear capacity is equal? That is moment equilibrium principle will help us to prove the shear stress on complementary planes that are perpendicular are equal. Okay, clear? So the answer is option A, or it is A. And now next question, you can see here axial force of 90 kilonewton is applied to a solid cylindrical shaft of diameter. So that is 90 kilonewton. He has given the data, and 40 mm diameter determine normal stress. Very simple. So normal stress sigma is equal to force divided by area. How much is the force that he has applied? 90 kilonewton. Kilo means 1000. Area is equal to how much? Pi by 4, 40 square. How much you will get? It is 71.62 Newton per mm square. That is in the denominator the area we got it is in mm square, and in the numerator I have substituted the value in Newton. So you get the value Newton per mm square. But the option that they were given as 225 MPa, 71.62 MPa. Yeah, we have option 71.62 MPa. What is MPa? So that is 1 MPa. MPa means megapascal. Mega means 10 power 6. Pascal means Newton per meter square. That is 10 power 6 Newton. 1 meter is equal to 1000 mm. That is 1000. For m, it will be square. So that is 1000 mm square. So 1000 square and 10 power 6 will get cancelled. Okay. So here 1000 square and 10 power 6 will get cancelled. So finally we get it is Newton per mm square. So you need to remember this. 1 MPa is equal to 1 Newton per mm square. Clear? Okay. So that is here 71.62 Newton per mm square means it is 71.62 MPa. Okay. So the option is option B. For the question, it is option B. And now, next question. What is the next question that he has given? It is length of the member. He has given a 10 meter long steel wire with a cross section, with circular cross section, 5 mm in diameter, subjected to a tensile load 5 kN, and the elongation in the wire is, that is E is equal to 200 GPa. First of all, here E is equal to 200 GPa. Clear? 200 GPa means 200 into giga means 10 power 3 mega. 10 cube MPa, that is 2 into 10 power 5. MPa means I just explained 1 MPa is equal to 1 Newton per mm square, that is Newton per mm square. So E value is equal to 2 into 10 power 5 Newton per mm square. And what he has asked, elongation of the wire, that is delta L is equal to, we have a standard basic formula, PL by AE. So what is P? It is 5 kilonewton. I am writing it as in Newton, 5 into 1000. L is equal to 10 meters. 1 meter is equal to 1000 mm. And A is equal to 5 by 4. And diameter square, it is 5 square. Into E is equal to 2 into 10 power 5. If you will substitute all the respective values in the locations, you will get it is 12.72 mm. So that is elongation in the 10 meter long steel wire by application of 5 kilonewton load will be 12.72. So option C is the answer. Clear? Okay. And the next question. Yeah, he has given the ultimate stress for a hollow column that carries an axial load 2000 Newton, that is load P is equal to 2000 Newton. He has given is ultimate stress is 2 into 10 power 5 Newton per meter square. If external diameter of the column is 0.3 meters, determine the internal diameter considering factor of safety is equal to 2. So first of all, we are going with what is the factor of safety? So factor of safety is equal to ultimate stress divided by permissible stress. Okay. So factor of safety he has given 2 and ultimate stress 2 into 10 power 5. Permissible stress will become how much? From this you can able to get permissible stress is equal to 10 power 5 Newton per meter square. Clear? Okay. Now permissible stress is equal to, obviously It is actual load divided by area of the cross section. So what is the permissible stress? Permissible stress is equal to load. So what is the load he has given? It is carries axial load divided by area of cross section. Permissible stress he has given, it is 10 power 5. Axial load, it is 2000 Newton. And area of cross section, as it is a hollow column. So hollow means it is 5 by 4. External diameter he has given, it is 0.3 meters. Internal diameter, he asked us to calculate internal diameter. Obviously, this internal diameter is less than 0.3, right? External diameter is bada, so more value, and internal diameter is less than external diameter. It is less than 0.3, and you can observe the options. He has given option 0.352. It is more than 0.3. You can eliminate the option 3 directly. Okay. So you need to get the values like 0.289, 0.187, 0.254. These are all options A, B and D are less than 0.3. Clear? So in any way, the option C will not become the answer. Okay. And the area of cross section, external diameter is 0.3 square. Internal diameter, I am assuming it is a small d. It is small d square. Okay. So if you will solve all this equation, you will get small d as 0.254 meter. Okay. So this you can solve by some calculator. So 0.254 meter. It is option D. For 7th question, the answer is D. Clear? We will go to next question. Okay. So a car weighing 100 kilonewton when fully loaded is pulled slowly up a steep inclined track by a steel cable. There is a cable here, no? You can observe that in the diagram. So that is, there is a cable here. Okay. And the cable has an effective area of cross section. That is, area of cable. He has given some information regarding cable. 250 mm square. And the angle of inclination is 30 degrees. So he has given this data here. Calculate tensile stress in the cable. Obviously, he asked us to calculate tensile stress. Tensile stress is equal to tension in the cable divided by area. Area of the cable he has given directly. Okay, he has not given any diameter of the cable like to calculate area by that. He given directly the area of the cable. We need to find out only what is the tension in the cable. So we will go with the, and he has given some extra information considering that no friction exists between the surface and the car wheel. So that is, there is no frictional forces are developed according to the information given below. I am taking, so here it is, there is tension in the cable, obviously, right? And there is a weight of the car 100 kilonewton. Obviously, weight will always act in which direction? Obviously, vertical direction. And angle of inclination, he has given, this is 30 degrees. Okay. And this 100 kilonewton will be resolved into two components, that is perpendicular to this surface and parallel to this. Okay. So if you observe this triangle A and B, C, at C the angle is 90 degrees and at B it has to become 60 degrees. That is, sum of the angles in a triangle will be 180 degrees. So 30 plus 60 plus 90, you will get it is 180 degrees. Okay. And then this angle will become 30 now. Okay. So the perpendicular component, this will become 100 cos 30 and the parallel component, this will become 100 sin 30. And if we consider the equilibrium along this line, along cable line, so T is equal to 100 sin 30. What is sin 30? Very simple. It is 1 by 2. So it is 50 kilonewton. It is T1. Okay, now what is the tensile stress? So tensile stress in cable is equal to T divided by area. How much is T? 50 kilonewton, and area is equal to 500. In place of kilo, K, I am writing 1000. How much is the value that I get? It is 2 zeros, 5, 5, 2 zeros, 2 zeros. The only remaining is 100. 100 MPa. Clear? So what is the option? Option B. Clear? So if you are not able to understand this, okay, you just post a comment, and I'll come in contact with you to clarify what are the doubts that you are facing. Okay, I'm teaching each and everything at very basic level. These are all very simple questions. Okay, free body diagrams, you can come across all the types of free body diagrams in engineering mechanics. Okay, so if you have any doubts still, so just post a comment. I'll give you my mail ID or else my personal details, so that I'll try to clarify your doubts. Okay, students, what is the next question? So yeah, he has given some question which is related to steel. Okay, so 420 mm diameter rivets join two plates of width 120 mm and thickness 10 mm. So that is, he has given how many number of bolts? 4 bolts. And what is the diameter of the each bolt? It is 20 mm. And what is the width of the plate? It is 120 mm and thickness it will be 10 mm. The allowable stresses in bearing plate, that is allowable stress I am taking in bearing, is equal to 100 MPa. Allowable stress in shearing, he has given 50 MPa respectively, and maximum safe load that may be applied in shear failure of the rivet and bearing failure of the plate respectively is, so how much safe load that we can apply over this joint by to cause no failure in the shear and no failure in the bearing. Now let me solve. The plate will be safe against shear, that is, to make the plate against the plate safe against shear. The safe load will be its shear capacity. The safe load applied should be shear capacity or shear strength. Shear strength of the bolt or rivet. Okay. Now we need to calculate what is the shear strength of the rivet. Shear strength of the rivet is equal to, I am taking this is P suffix S. I have a formula. Shear strength of the rivet is equal to allowable shear strength into N into pi by 4 T square. Allowable shear stress into area of each rivet. Similarly, like that, how many number of bolts were there? So what is the allowable shear stress? 50. How many number of bolts? It is 4 number of bolts. What is the diameter of each bolt? It is 20. So you will get the value as 62.831 kilonewton. Okay, so that is 62.8 kilonewton is the safe load that we can apply over the plate against shear. Now, how much is the safe load to make, that is, how much is the safe load to make the plate safe against bearing? So let me solve the puzzle. To make the plate safe against bearing, we need to calculate bearing strength of the plate. Bearing strength of the plate is equal to PB. I am taking it is PB. Allowable bearing stress into area of the bolt in bearing. In bearing means the area will become diameter into thickness. How many number of bolts are like that? Into N. That is, bearing allowable stress is 100, diameter is 20 and thickness is 10. Similarly, 4 bolts, 80 kilonewton, that is PB. So the bearing strength of the plate for the given conditions is 80 kilonewton. That is 80 kilonewton load. 80 kilonewton load we can be applied very easily over the joint without causing bearing failure. Okay, so the answer will be 62.83 and 80. So the option is C. Okay, it is 80 and 62, but he has given allowable bearing stresses. First of all, he has given in the bearing and then shearing, but he asked reversely. Okay, first of all, he asked us to safe load in shearing and safe load in bearing. So that is, safe load in shearing is 62.8 and safe load in bearing is 80. So the answer you need to choose very properly. Okay, so it is option C. And now, in the same problem, determine safe load if minimum average tensile stress in the plate is tensile stress in the plate. So we need to apply certain load. By applying that certain load, it has to be safe in tension. That is, how much load we need to apply? Obviously, it is tensile capacity. Tensile capacity of plate is equal to allowable tensile stress into allowable tensile stress into area of cross section, especially that is gross area of cross section. What is allowable tensile stress? It is 15. Area of cross section, how much is that? It is 120 is width and 10 is thickness. So you will get it is 18,000 Newton. That is 18 kilonewton. What is the answer? It is A. Okay. So we have discussed in this problem especially 3 capacities: shear capacity, bearing capacity and tensile capacity. For calculation of shear capacity, allowable shear stress into area of the each bolt, that is shear capacity of each bolt, that entire value has to be multiplied with N. Okay, N means the number of bolts, how many number of bolts are there. Similarly, the bearing capacity can be calculated by multiplying diameter and thickness of the plate. So that is that inside portion will be having some bearing stress, that is bolt portion having some bearing stress. So bolted inside area is diameter into thickness and allowable bearing stress. This is bearing capacity of one bolt. Similarly, how many number of bolts into N. Okay, but tensile capacity, it is not related to any particular bolt. It is related to entire plate. Okay. To get tensile capacity, we need to multiply the gross area of the plate with allowable tensile stress. Then we will get tensile capacity. So here we got the answer as 18 kilonewton. So 10th answer is A. Okay. And yeah, if you see this question, you will get confused. He has given so big diagram, but it is very simple. Okay. So what he has asked? In the figure shown, the average normal stress and average shear stress. Simple normal stress, you need to get normal force and the area over which it is acting. And to calculate average shear stress, you need the force, shear force and the area over which it is acting simply. On which page he has asked, especially he asked in this plane, inclined plane. Okay. So first of all, we need to get the area of this inclined plane. You can see there is. So you need to concentrate here. First of all, he asked us to calculate stresses. To calculate stress, we need to get first of all the inclined portion area. In this diagram, inclined portion area. So you can see this is the diagram. I'm just drawing this. So he has given this. So this is 30 degrees and this width he has given 4 meters. So we want to get this is E, he has given it is A and I'm taking it is some X. So if I will take cos 30, right? Cos 30 is equal to adjacent side. What is that adjacent side? It is EX. So what is the value of EX? It is 2 mm. That is given in the diagram. EX divided by hypotenuse. Hypotenuse is AE. So AE will become EX divided by cos 30. What is EX? It is 2 divided by sin 30 is 1 by 2. Cos 30 is root 3 by 2. So that is root 3 by 2. So finally AE will become 4 by root 3. So this is 4 by root 3. Now what is the area of this? AEFB. I am writing here area of AEFB portion. It is 4 into 4 by root 3. That is 16 by root 3. Clear? So first of all, we need to calculate the area over which this normal force and shear force are acting. So that area is 16 by root 3. And now this is the force. How much? 50, right? 50 Newton he has given, and he has given this is 30, and this 50 will be resolved into perpendicular component and parallel component. Here it is. This will become 30. This is 50 cos 30. This will become 50 sin 30. This is shear force. This is normal force. Why this is shear force and normal force? Because 50 cos 30 is acting perpendicular to the surface. 50 sin 30 is acting parallel to the surface. Now normal stress sigma is equal to normal force is 50 cos 30 divided by area 16 by root 3. So you will get normal stress as 4.6875 MPa, and here shear stress tau is equal to shear force is how much? 50 sin 30 divided by 16 by root 3 area, you will get this is 2.706 MPa. Okay, so 4.6, 2.706, 4.6, 2.706. Okay, he has given the answers. You can observe this option C and D. Just reverse. Okay, so first of all, what is he asked? First is normal and then shear. First normal, how much we got? It is 4.6 and then 2.7. So 4.6 and 2.7. Okay, he has given in the option D, it is reverse. So be careful in choosing the options, even though if you solve the problem very properly, but you need to choose the options very carefully. Okay, everyone, is it clear? We are about to complete the assignment number 1. So the last question, it's the most important one. So he has given a stress tensor in the problem. The state of stress at a given point is given as shown. Calculate principal stresses in megapascal. Okay, so he has given stress tensor as, so that stress tensor is equal to, you need to compare this with standard format, sigma x, sigma y, sigma z, tau xy, tau yx, tau xz, tau zx, tau yz, tau zy. Okay, so this is a standard format. So what is that he has given? It is minus 10, minus 20, minus 15, and this will be 5. Here it is 10, here it is 10, and it will be 15. So we need to calculate principal stresses. So principal stresses are the roots of the following equation. So for this question, I am writing solution each and everything very properly. Okay, because it is a long answer question, they will ask it directly for 2 marks. So you need to have some patience to solve this question. The principal stresses are roots of the following equation. So that is sigma n cube minus I1 sigma n square plus I2 sigma n minus I3. Okay, so here sigma n, this you can remember very easily, that is first plus minus alternative symbols, and the power will be 3, because it is a 3D tensor, 3-directional tensor of the stress. So the maximum power is 3, and then 2, and then 1, and then 0 finally. Okay, so it's very easy. कोई ज़्यादा content नहीं इसमें, ठीक है? Now, first of all, we need to find what is the value of I1, I2, I3. So now I1 is equal to summation of the diagonal element, that is summation of normal stresses. So that is sigma x plus sigma y plus sigma z, that is minus 10, minus 20, minus 15, it will be minus 45. And what is I2? I2 is, delete third column, only 2 columns, third column and third row. So you will get sigma x, sigma y, tau xy, tau yx. Determinant, calculate the determinant and delete first row and first column. You will get remaining sigma y, sigma z, tau yz, tau zx. Calculate the determinant plus delete middle column and middle row. You will get the determinant in terms of x and z. Sigma x, sigma z, tau yz, tau xz and tau zx. Calculate the determinant. You will get it is 300 rupees. It is not rupees, bhaiya. It is not 300 rupees. Okay, it is 300 because he hasn't given in MPA. He asked us to calculate in MPA, so all the values he might be given in MPA itself. And finally, I3 is determinant of the given matrix. Determinant sigma x, sigma y, sigma z, tau yx, tau xy, tau zx, tau yz, and tau xz, tau zy. So this is very important. Writing 3D tensor is the most important. So if you will calculate determinant for this 3D matrix, you will get it is 3, 1, 2, 5. So substitute to put all these values over there in the 3D equation, that is quadratic equation. Sigma n cube minus, what is I1? It is minus 45, minus of minus 45, sigma n square plus 300 sigma n minus 3125 is equal to 0. You can solve this by using a calculator. Calculator gate में नहीं देता ना. I don't know. You have to solve the values. That is, you need to check these values by choosing options. Okay, not from question to answer. It is from answer to question. Reverse में आएगा. You need to come like that. Okay, so then sigma n values you will get it is 5.44 minus 17.37 and minus 33.07. These are all the principal stresses. Okay, so many people will think that these are all very tough questions, very long answer questions, but these are all the questions were prepared by obviously great professors from IITs. Obviously GATE exam will be conducted by IITs. Okay, so these are the most important conceptual questions you need to know. Okay, then you can able to face the GATE exam very easily. I hope everyone has understood the way that I have explained. If any doubts, you just text, you just put a comment and I'll try to come in touch with you. Okay, students, everyone, clear? समझ आया? कोई दिक्कत नहीं इसमें? वो छोटा प्रॉब्लम्स है ना? Okay, thank you students. We will meet with some other assignments in some other topics, some other subjects. Thank you.